All right, welcome to your first set of notes this school year that are going to be completed partly on a video. Now my videos, just to kind of give you a heads up, I usually start it with a joke, something like, why is 6 afraid of 7? Because 7, 8, 9. Or words of wisdom, or just a saying. For instance, did you know our eyes water when we yawn because we miss our bed and it makes us sad? So, or sometimes you might see a short little video clip in this video. So regardless, we're going to go ahead and get started, and then you'll see that we don't do every single problem on the video, and that's because we'll do it together the next time I see you in class just to reinforce the concept. So today's goal, what we're talking about, and I will have the topic always up here at the notes, solving 1- and 2-step equations. Okay, so for these 1-step equations, we're going to solve each equation. We're going to show all work. Showing all work means to justify your answer. And I will say that is always a weakness for my students. They try and do too much in their head, but you have to show me in writing what is going on in your head. So for instance, we'll go ahead and start with number 1. For number 1, to solve for the variable, which is x, that means to isolate it, to get it by itself on one side of the equal sign. So that means we're going to look at what else is on that same side. We have a negative 23. So we always do inverse operations to remove the negative 23 to put it on the other side of the equal sign. So inverse means opposite, opposite operation. So if I have a negative 23, the opposite is a positive 23. Something called the property of equality. If you do it to one side, you have to do it to the other. Equality because of that equal sign. So moving left to right, top down, negative 23 plus 23 is 0. We don't write anything. We'll drop down that x, drop down equals. Then I have negative 15 plus 23, and that is 8. We're going to remember to box in and circle our final answers. Let's go ahead and work on number 2. Number 2, I have 2 4/10 is equal to m plus negative 3 7/10. You can go ahead and clean this up. You are not required to clean it up. What I mean by that is this double sign. So I will know, okay, well, I'm working with a negative 3 7/10, or if you need to, you clean it up, because a positive times a negative is a negative. But anyway, to isolate the m, to solve for that variable, what we're going to do is we are going to do inverse operations to get it by itself. So that means I'm going to add 3 7/10 to it, because that'll give me 0. But if I do it to one side, we have to do it to the other due to something called the property of equality. Now this property of equality we will talk more about in tomorrow's notes. So my answer here is, when I add that together, is 6 1/10 is equal to m. If you want to rewrite it, so m is equal to 6 1/10, you can. Remember that it's called the symmetry property, but I typically will not rewrite it. Well, I take that back. Every once in a while I do. Anyway, moving on to number 3. We have negative 4x is equal to 60. We're going to remember that we have negative 4 times x is equal to 60. So we're going to do the inverse operation of times, or multiplication, which is division. So I'm going to go ahead and divide by negative 4. If I do it to one side, we do it to the other. So I have x is equal to, well, negative 4x divided by negative 4 is just x, or 1x. 60 divided by negative 4 is a positive 15. Now, this next part, to get rid of a fraction, we're going to multiply by the reciprocal, or we're going to cross multiply. Oops, let's spell cross correctly. Today's focus will be to work with the reciprocal. Remember, the reciprocal is a fraction flipped. Okay, so I'm just going to write that underneath. You only write it if you need that reminder. Cross multiplication, we'll do that a little bit later, more of a focus on that later with a homework assignment. Anyway, coming to number 4. Number 4, I have a over 9. Remember, we're solving for a. And remember that there's that understood 1 in front of the a. So really 2 schools of thought on this one. You can go ahead and follow this rule that I said, multiply by the reciprocal. The reciprocal is going to be 9 over 1. It looks like you have to squeeze it in there. And if you do it to one side, you do it to the other. Or you can just know that a divided by 9, the inverse operation of that is to multiply by 9. So we're multiplying by 9 on both sides. We get a by itself. Okay, 9a divided by 9 is just a. And then on the other side, we have negative 4 times 9, which is negative 36. I forgot to tell you guys, but if you find that I do go too fast in the videos, go ahead and pause and finish writing to catch up. So next, for number 5, I have 2/3 x is equal to 10. And to solve for x, we're going to multiply by that reciprocal, where I will have 3/2 is the reciprocal. If I do it to one side, I'll do it to the other. And so 3 times 2 is 6. 2 times 3 is 6. So 6 divided by 6 is 1. So we'll drop down that x. Now over here, this is going to be some mental math. Actually, for notes, I won't. We multiply across with these fractions. 3 times 10 is 30. And I still have divided by 2. 30 divided by 2 is 15. So I will point out that the step that I have right here, that can be mental math. But we'll review this together in class. So number 6, when I see you next, we'll come back and do that together. Okay, let's go ahead and move down and talk about solving a two-step equation. For a two-step equation, we have inverse operations we will perform inverse operations to do undo subtraction and addition, moving the constant term, and then we'll also do multiplication division to remove the coefficient. Same thing, we're going to solve each equation, show our work, check our answer when indicated. So for this problem, number 7, we're going to isolate that variable term last. So that means that I'm going to focus on that plus 2. And then notice that it's step number 1 where we're working with that constant term. We're going to do the inverse operation or the opposite. So we have a plus 2. So the opposite or the inverse is a negative 2. If I do it to one side, we do it to the other. And then we just go left to right and do our math from top to bottom. So that 3x drops down, 2 minus 2 is 0, we don't write 0, equals drops down, negative 1 minus 2 is negative 3. Now we're at step number 2 to solve for x. So if I have 3 times x, the opposite here is to divide. We're going to divide by 3. If I do it to one side, we do it to the other. 3x divided by 3 is 1x, but we just write the x. Negative 3 divided by 3 is negative 1. And that's it. We're going to quickly do the check here. So what we do with the check is now that x is equal to negative 1, we're going to do that substitution and solve. So 3 times negative 1 is negative 3, plus 2 equal to negative 1. I keep simplifying. Negative 3 plus 2 is negative 1, and we see that that equals negative 1. My check is good. We'll do 8 together the next time I see you in class. Let's move on to number 9. For number 9, I have 1/3 x plus 5 equal to 7. Same thing. We are going to go ahead and do our variable term last. So we're going to work with our constant. It's step number 1. We do addition, subtraction to remove the constant. So we do the opposite operation or the inverse. If we do it to one side, we do it to the other. Again, that's called property of equality. When I work this one out, I have the 1/3 x I drop down, 5 minus 5 is 0, drop down the equals, and then 7 minus 5 is 2. We are going to now get rid of this fraction by multiplying by the reciprocal, which is 3 over 1. If I do it to one side, we do it to the other. 3 over 1 times 1/3 leaves me with 1, so I have the 1 that I can drop down, the x I can drop down. 2 times 3 over 1 is 6. Same thing, we're going to do the check. So show the work. We're going to substitute 6 in for x. And then we solve. 1/3 times 6, or 1/3 of 6, is 2. Drop down everything else. 2 plus 5 is 7. 7 does equal 7, so my check works. We'll do 10 together the next time I see you in class. So that means let's flip over our notes. We are on the back. We're going to practice some story problems. Okay, now with these story problems, make sure you read the directions, and this will be the setup or the process for all of the story problems that we do this school year, where we will be labeling the variable. We're going to write an algebraic equation for each situation we're going to solve. We're going to also write our answer as a complete sentence when we're done. So for number 1, we have Sid is 4 years younger than his brother Tipton. Sid's age is 76. How old is Tipton? So I'm going to underline and reread. So Sid is 4 years younger than his brother Tipton. Sid's age is 76. How old is Tipton? I underline always the question or what we're solving for. The reason I do that is when I go to label my variable, what x is, that tells me, well, we're solving for Tipton's age, or how old Tipton is. I think this Tipton's age is a bit more concise. The next thing I'm going to do is create that equation. Okay. The x is the unknown, but we know that Sid is 4 years younger than Tipton. So I will show x minus 4. That's my 4 years younger. We know Sid is 76, so we'll have it equal to 76. Again, that's my equation. Now we solve. We do inverse operations. We have x is equal to 80. My final answer, the last thing we're going to do is we're writing that sentence. Tipton is 80 years old. Okay, number 12, trying another one. Assume that 1/7 of all people have blonde hair. The number of blonde-haired people in the group is 35. How many people are in the group? Okay, so again, I'm going to reread and underline. 1/7 of all people have blonde hair. Number of blonde-haired people in the group is 35. So blonde-haired people in the group is 35. How many people are in the group? That's what we're solving for. So let's label our variable, our unknown. This is the number of people in the group. Next, my equation. Okay, 1/7 of all people have blonde hair. Okay, so 1/7 of all the people. All the people is my x, my unknown. They have the, and then of that, that's 35. It is, remember the word is does mean equal, and we see that it's working for our first two story problems. Now we'll go ahead and solve. When we solve a problem like this, remember we're going to multiply by the reciprocal when we have a fraction times our variable. So that's going to be 7 times 1, 7 times 1. 7 times 1/7 is 1, so I can just drop down that x. 35 times 7 is 245. And that makes sense. We're trying to figure out how many people are in the group. So if 1/7 is our blonde, then the value or the answer for my group should be larger, and it is. And then to write a sentence to finish this one up. There are 245 people in the group. Okay, now number 13. 13, we have jar candles at the candle company cost $4. Nikki spent $92 buying jar candles for party favors. How many jar candles did Nikki buy at the candle company? So jar candles at the candle company cost $4. Nikki spent $92 buying these jar candles. How many jar candles did Nikki buy? So that's what we're solving for, the number of jar candles bought. And so we know that she spent a total of 92. So 92 is one side of the equal sign. We know that they're $4 each. It's going to be 4 times our unknown, how many she bought. Okay, that's our equation. Our next step is to solve. 4 times x, the inverse of times is to divide, so we'll divide both sides by 4. We have x is 23, and so we'll write our sentence that Nikki bought 23 candles. Number 14. At the market, Meyer buys a bunch of bananas for 65 cents per pound and a frozen pizza for $4.99. The total for his purchase is $6.94. This is without tax. How many pounds of bananas did Meyer buy? Okay, so again, I'm going to underline. He buys bananas for 65 cents per pound. Frozen pizza for $4.99. The total is $6.94. How many pounds of bananas did Meyer buy? So that's my unknown, okay? Almost always it's in that question. So let's write what our variable equals. Our variables and what we're solving for is the number of pounds of bananas. Next, my equation. Okay, so we know that there's a frozen pizza for $4.99. We know that there's a bunch of bananas for 65 cents per pound. Well, you know what? It's that pounds. That's my unknown. See where my x is? So I can go ahead and write it as 65 cents times x, and our total is $6.94. Okay? So if you have any confusions of how I came up with that equation, again, reread the story problem and really study that equation. Okay, next we're going to just solve. Okay, remember we're going to do our variable term last, so it means our constants we're going to move to the other side first. So when I do that, and I subtract, I get $1.95. I'm going to go ahead and divide both sides by 65 cents. When I run out of room, we just come to the top of the next row, and I find that x is 3. Okay, Meyer bought 3 pounds of bananas. That's our sentence. I wrote a bit big on this one, so I'm about to run out of room. Okay, so these last 2 story problems, these again we'll do the next time I see you in class. And I want you to take a notice of the time today. It's almost 18 minutes, right around 18 minutes. My videos, I try not to go over 20 minutes. That's unfortunately not always a guarantee, but I do try and keep them as close to 15 minutes as possible. So 18 is pretty good, especially you could see we covered a lot in these notes today. Okay, thank you again for taking the time to watch these videos and copying everything down. Remember, completing the video is part of your homework grade, so if you don't complete the video for class, then you do not get full credit on your homework. And also, lastly, I know it's tough to keep hearing my voice, you know, twice in one day, but it is important to listen to the videos, make sure that you are listening to the volume with headphones or just in your bedroom with the Chromebook turned up. Okay, thanks again, and I'll see you next time in class.